molecular graphics, movies, documents, and presentations. My name is Andrew Ori, and I'm a Senior Research Scientist here at MolSoft. And if you have any questions after the webinar, please feel free to contact me. You should have my email from when you registered. During the webinar, if you have any questions, I would try my best to answer them. You can use the text chat. But if we do not have time to answer them during the webinar, at the end of the webinar, we'll have time for questions. So the key topics for today are a new feature as part of our software is easy 3D stereo viewing using Anaglyph Stereo. I'll show you how to do that. How to annotate, how to read in protein structures and other molecules, color them, and change the 3D representation. How to superimpose molecules. How to prepare publication quality molecular images. How to make fully interactive 3D slides, and then how to display those interactive 3D slides in Windows, PowerPoint, or in web browsers, Safari, Firefox, or Chrome, and also how you can read those into our iPad and Android device. The program is called iMolView. And then I'll show a couple of ways to make movies. So to get started, what you would need is, for most of what we're showing today, are the three free products that we offer. Active ICM is the plugin, which enables you to view fully interactive documents and in the PowerPoint or on the web. So it's a small download. ICM Browser is the main desktop platform for Windows, Mac, and Linux. And in this, you can build slides and display structures and read in the PDB, which we'll be showing today. And then there's iMolView, which is iMolView Lite is free from the Apple Store. iMolView, the full version is 99 cents, but iMolView Lite is free, and iMolView is also free from the Google Play Store as well, for Android devices. So you can download this from molsoft.com/download.html. Go here. So we'll just start with some slides just to introduce what the concepts we're going to show. The first one is Anaglyph Stereo. So now there's just a single button you can press, which will activate the stereo. So all you need is like a cheap pair of red and cyan glasses, which is less than $10. You no longer need expensive monitors or hardware. You can view these directly on your monitor, or you can project in stereo. If other people in your group have these glasses, they can view from a projector. You can also display stereo on your iPad or Android device, and these images can be written out as an image and printed. So once you read in a protein structure into ICM, then there are ICM Browser. You can then annotate the structure and color it and change the representations. And all these features are in this tab here called Display tab. There's also a Light tab and Labels tab as well. And we'll be showing that in the demonstration. You can also in ICM Browser display the receptor surface of your ligand. So if you have a ligand bound to a protein, you simply right-click and it will display. Right-click on the ligand and it will display the surface, colored by binding property such as hydrophobic region in green, hydrogen bond acceptor in blue, and hydrogen bond donor. Hydrogen bond acceptor in red and hydrogen bond donor in blue. And the kind of opposite of this is what we call the ligand surface. This gives a surface of the ligand, so the coloring is the opposite to the receptor in terms of matching properties. And this representation gives you a better view of where there's cavities to build if you're interested in building a new ligand or adapting this ligand. You can see where you can build into that. Okay. So we'll go to the ICM. So when you open ICM Browser, which is the free download, you'll see basically what I've got here, except for some of these menus, which are redundant for this workshop, this webinar. So to read into ICM, we have a direct link to the protein data bank, and there is a search tab here, and we can enter the PDB code for the protein that we're interested in. Press return. You can also link to a local database if you wanted to, or you could read in your own PDBs, go by File, and then Open, and that will display. You can also use the command line for everything to show here, but we won't be looking at command line today. So to read in PDB, it's read PDB, and then the code in quotes. Okay, you can also search by a string, so you could type kinase, for example, and you can also search Uniprot, Pocketome database, and other databases here, which will bring in that information. So we've loaded in a kinase structure, and we can see it's loaded in the 3D window here, and also in the ICM Workspace. It tells us the code. It tells us it's an X-ray structure, and it's at 2.1 angstrom resolution. And then we have a list of all the molecules in this protein. So we have two protein molecules, and then some chloride ions, and then 2 ligands in each of the 2 protein molecules, and then the waters aren't displayed. Just for clarity, I'm going to change the background to white. So the coloring, as I said, is in the display tab here, and you can change the background color by right-clicking on a color in the tab here. So we have the 2 molecules. We can use the left mouse to rotate, and then certain regions of the 3D graphics window are devoted to certain operations. So hopefully in WebEx you can see that the mouse button changes here from a rotation, and if I move it along a little bit, this panel here going down here is devoted to being able to zoom in and out. Or alternatively, you can use the middle mouse button to do that. Likewise, the top of the screen is devoted to Z-axis rotation, and the bottom section of the screen is devoted to translation, so you can move the structure around the screen. Alternatively, you can also use these buttons here, so you can. That means you have to click on the button, then translate, and then click back onto there to rotate. So these are helpful. So these panels at the side are useful for screening and for zooming in and rotating. And the right-hand side we have clipping planes as well, so you can click the rear plane here, click the front plane here. Okay. So coloring. We'll move on to coloring with structures and annotating them. So we have two molecules. It might be convenient for us just to color each molecule by a unique color, so we know which one is the A subunit and which one is the B subunit. So to do that, we have to go to the Display tab, and we have the representation buttons here. So to change the representation coloring, you click and hold on the ribbon. You choose Color by Molecule, and that will give each molecule a unique color. So the yellow is the A subunit. Okay. We can see that what we have displayed, we have Stick. This button is pressed down, it's kind of blue. We also have Ribbon. So if you want to remove all the stick representation, we just click on here, and that removes it as well. You can see we also have this button here, which is a residue labeling button. We have some labels of some of the ligands and some of the ions by default, we can just remove that. So we might be happy with this image. If you want to save this viewpoint and rendering and all the information in this one image, we can click on this slide button here. Down at the bottom of the screen, there's it's like a camera button. And you can see that we have now in the ICM Workspace, we have a slide, one slide. So basically that means if we zoom in, zoom out, we can always return directly to that slide by double-clicking on the slide button here. So it's stored all that information in one slide. Okay, so this is a ABL kinase, and we're going to look at a little bit more detail about the kinase receptor. So we're just going to look at the A subunit. So to undisplay and display molecules, you can just use the ICM Workspace to undisplay. Clicking here. So now we just have the A subunit. If we use the center button, this will center the structure. And we have the N-terminal lobe of the kinase here, and the C-terminal lobe here. So it may be helpful to color by secondary structure, for example, that colors helices red and beta sheet green, or we can color by secondary structure segment. So you just click and hold on the button, and you choose secondary structure segment. Okay. So this kinase has been crystallized with Gleevec, which is a type 2 kinase inhibitor. So it binds in the hinge region of the kinase here, and it extends out into a hydrophobic region here. And it means that this DFG loop has moved out of the pocket to accommodate this inhibitor. So we'll just annotate a couple of things and save them in slides. One of the residues here is called the gatekeeper. There's a threonine. So if you expand in the ICM Workspace, you get the list of the residue, the sequence. And so you can just select a residue here, which is the threonine, and we can display that in stick. So if you click and drag over the residue code, you can just click on the stick, and that will display it here. We made a selection, so if we zoom into that threonine. We can label that threonine by clicking on the residue tab here. You can see that the residue label is there. You may want to change the coloring of the label, so you click and hold on the residue label button, choose color, green, and then we can also drag the label to a more convenient point, or a better point. Okay, so this could be another slide, so we can just click on the slide button here, and now we have two slides. So if we click on the slide 1, we go to that one. Slide 2, we jump to the threonine molecule here, a threonine residue there. Okay. We may also want to point out just change that color. We may want to highlight the fact that the DFG region is out. The DFG loop is out. So we can select that region around there. So the DFG we see here, this motif, and we can label that region with a 3D label. So we can so we've got 2D, 3D label, and we can right click and we choose annotate, make site, and we can give it DFG out. You can see now we have this 3D label with an arrow to that region. You can move the arrowhead any way you like, using the middle mouse button. Okay, so maybe we want to just zoom in here, or just make it a bit smaller. Use the middle mouse to make it smaller. And we can make another slide. DFG is out. Okay, so for our final annotation, maybe we want to look at the salt bridges, for example, that are in the structure. So one way to do that would be if you knew the residue numbers that made there's an important salt bridge between the alpha C of the kinase here with the beta 3 strand here, which when it's activated, there's a salt bridge between those two residues. So if you knew those residue numbers, we could just select them in the sequence. But I just wanted to show some selection tools. So one way to select is to right-click and drag over a region, and you can see we have green crosses and blue selection in the ICM Workspace. Alternatively, you can use these tools here. So there's a lasso button. You can use this button to pick individual atoms, and there's also a residue picking button as well. So any selection button is shown in green, and these as well are selection buttons. So you can change the selection from an atom selection to residue. So if you select one atom on a residue, you can propagate that to residues. You can also do that using this R button here. You can remove, toggle, add different selections. And this button allows you to choose different properties. So if I go to the residue tab, I can select all the charged residues in this protein. You see that they're all shown in green here and all selected in blue here. If we use this R and we propagate that selection to all atoms, we can display all the charged residues in the protein. We can look around for different salt bridges. The salt bridge that we're interested in is from this beta 3 here to this alpha C here. So the two residues involved are here. So we can just zoom in to that region. If you right-click and drag roughly in that area, you can zoom into that salt bridge. We can use this button here to label those two residues, just by clicking on here. You can see that those two residues are selected. So once they're selected, we have green and green here. We can invert the selection, which is this exclamation mark, and that will select everything else. And then we can just undisplay all the other salt bridges. So we're just left with this one salt bridge. It looks a little bit far away. We can measure the distance to see how close that salt bridge is. So we can click on this in the display tab. We have distance measurements of a way of measuring angles and dihedral angles and distances. So if we click on this distance button, we can click on one atom here and just one atom here, for example, and the distance is shown. If we right-click on the distance, we can change the color and edit the font. Make it a bit bigger. Okay. So the distance is there. So that could be our fourth slide. We can click on the camera button here. Okay, so we can toggle through each of our slides again just by double-clicking in the slideshow here, or you can toggle through at the bottom, go through each of the slides here. Okay, so we may want to compare our kinase with another kinase, for example. So one way to do that is we can read in that other kinase structure, and the code for that is 1OPK. Go to search and then type search tab and then just type the code. Okay, so you can see now that one OPK has been written in, loaded in. It's got a resolution of 1.8 angstroms. It has one protein molecule and one ligand. So the two structures are not superimposed. And we'd like to, for this example, we'll just superimpose them and then we'll compare the binding pockets of these two proteins. So we can double click on one OPK, that was selected. We hold the control key and double click on the A subunit of one IEP. And then we go to the display tab and click on superimpose button here. It asks you which of the two molecules you want to keep, two objects you want to keep static. We'll just keep one IEP static. And now they're superimposed. Just for clarity, I'm just going to undisplay part of the N terminal of one OPK. Okay. So both of these structures are superimposed. Just undisplaying some things that are not interesting for this thing. So that superimpose button is pretty powerful. So it superimposes anything you select. So obviously, the kinases, you have two different lobes. You have the N-terminal lobe and the C-terminal lobe. So you could select the N-terminal and then superimpose. Or alternatively, you could select the residues surrounding the ligand binding pocket and superimpose. Like this. Just tweaks it a little bit. And just for clarity, we're going to color each of the objects a separate color. So I'm just going to undisplay that. Color by the ribbon, go color by object. So we have two objects superimposed, and we can make another slide. We look at the ligands. We already saw Gleevec in one IEP, and one OPK has a type 1 inhibitor which sticks closely to the hinge region and doesn't extend into this pocket. And so we can also see one OPK, the DFG loop is in this case. So we can also color the sticks by object color as well. So if you click and hold on the stick and say color by object C, this will color the carbon of each of those ligands by the same color as the ribbon. So we could make another slide if we wanted to, but we won't in this case. So we're just going to look at the surface of the pockets. If we right-click on the ligand, we can say there's an option called Pocket, and we can choose Receptor Pocket, and just go OK. So this is the pocket for the type 2 kinase inhibitor, and we see we have another object in the ICM Workspace called Meshes. So if we can right-click on there, and we can color it yellow to match the coloring of that structure. And then we can make the pocket of the type 1 inhibitor, which is shown here. So if we right-click on that, and say Pocket, Receptor Pocket, let's go OK. And then we can color. You see that each of these pockets, we now have two, and they're each labeled by the object that they're made from. We just right-click and say Color, Green. You can see how much the movement of that DFG opens up an extra cavity here. Okay. You may also be interested in the the binding properties of that pocket, like I showed before. So to do that, currently each of these objects are X-ray structures as XR, so we don't have any hydrogens added to them. So in order to color by properties, we need to convert them to ICM objects. And to do that, you load in the structure, you right-click on the object, and there's an option called Convert PDB. So the ICM will add hydrogens and optimize them. If you're not interested in the waters, you can delete the waters. And we can optimize the positions of asparagines and glutamines and histidines to improve the hydrogen bonding network. And there's an option here that's quite important. If there's if this is not selected, then if there's a residue where one or two atoms have been resolved by the crystallographer, but the rest of the chain of the residue have not, so that they're missing atoms in the residue, ICM will add those missing atoms. If you don't want that to happen, you can just click here and it will hide those missing side chains to do that. So we go OK. Usually takes a little bit of time to run, especially if you're optimizing the hydrogens. It might take a couple of minutes. So I have one already converted. Yeah. Let's give it a different name. Okay. And we're just going to be interested in the A subunit with the drug inside. And we can then color the binding pocket by property. So we right click, which is pocket, receptor pocket. We can display hydrogen bonds, and we could label if we wanted to, but we go OK. Okay, so now we have the pocket colored by property. So we can we can cut through the plane in order to cut through the pocket to see the ligand slightly covered. We can see hydrogen bonds here, and the hydrogen bonds are listed here, so you can toggle them on and off using the hydrogen bond here. You can also edit the font and things like that for the way they're displayed. You can also change the labeling. There's the hydrogen bond button is also shown here. Okay, so we could add this as another slide. So now we have quite a few different slides. Another useful option is called a viewpoint. So if we like this position, let me just undisplay the meshes. Let's color. So if we really like this viewpoint, for example, sort of got the alpha C here, we've got the glycine-rich loop here. If we like that viewpoint, we can save it by clicking on this button here called, it stores the current viewpoint. It's like an eye, and we can give it a name, pocket. So therefore, if we read in one OPK, for example, and change positioning here, we just double click on the pocket, it saves the exact same positioning and viewpoint as the previous slide. So if you're making lots of comparisons of binding pockets, you can save this. You can maybe go for another one, a view from the top or something, the N-terminal, and then you can always, then whichever structure you show, it's already saved that if we change the positioning, we can always return to that N-terminal view or go to the pocket view here. Okay, so we're going to move on to saving images and nice images. But before we do that, I'll just show you the different different graphics effects that you can have. So we have occlusion shading. So if you have a surface, you can shade it so that the deeper clefts and you can are shaded darker, so you can see the pockets and the spaces better. We also have this option called moleskin. So if you have a surface, so molecular surfaces are automatically generated and are assigned unique colors with occlusion shading automatically included. Carbons of each molecule are colored by its own consistent color, and the labels are colored accordingly. But it also flags, it colors patches where there are contacts. So here we have a protein-protein interaction site, and where the contacts are, it's nicely colored. We also have fog, so you can display and you can make fog into the background and highlight certain points. We have CPK cap clipping. There's transparency for ribbons and sticks, and there's also sketch accents, which gives a colouring around the outside of the representation and makes it a bit clearer. And there's also shadows. So just a couple of those. So to activate the ribbon transparency, you can click and hold on the ribbon button and choose transparent, and then transparency is shown. I should have pointed out that you can change the width of most of the representations by clicking on the plus and minus button here. And also, if you click and hold, there's other options such as wide ribbon, cylinders, smooth ribbon, and the same with the stick as well. You can change the ball to stick ratio to 1, for example, to make it flatter. You can change, you can make the stick transparent. If you display the ligand in CPK, by default the CPK is transparent with the H-stick underneath it, so you can see both together. And with the stick, we can change the coloring as before by object, occupancy, variety of things. You can change the style to chemistry, for example, or there's different styles for the stick, or just plain, as shown here. So here we have kind of the fog button is usually activated by default, so it means that we can change we can pull away the back using the clipping plane buttons here. All the clipping plane buttons are in yellow. So the rear clipping plane, front, we can cut away as well. So just final thing, we'll just show the how to make surfaces of the whole protein. So go to search one. Let's see. It's an SH3 domain. It's going to delete 2 of the molecules. can delete the water. By double clicking, we move in, we zoom in. So it has it's colored by molecule. See, it has a peptide or protein bound to it. So we can see the contacts between the protein, between the peptide and the SH3 domain. We right click on here, say skin mesh, and choose publication view. This will make the surfaces of these two proteins. Okay. So we have the two surfaces. We can undisplay one, and you can see that the blue one is colored by contact here. Okay, so once you have an image that you like, you can save it as a PNG or GIF or JPEG by using this button here. So if you click and hold on the button, we have copy image to clipboard, and you can cut and paste that image. When you're making an image, it's best to toggle the anti-aliasing and also high this button here, which is high quality. That will remove some of the small imperfections on the edges of the structure. So you can click and hold and say write image, and that will write a quick image to your current directory. You can also click and hold and choose write image advanced, and that gives you a few more options, such as the size. You can have transparent background. You can define where you want to save it. You just go OK. Okay, so moving on to the final things. So the active ICM. So this is a method that was developed by MolSoft, by Ruben Abagayan, Max Totroff, and Eugene Rausch, in collaboration with the Structural Genomics Consortium. So the Structural Genomics Consortium still are producing lots of structures, and they don't necessarily have time to publish them in traditional journals. So they wanted a way to get the structures and fully annotated structures out to the general public as soon as possible. So we worked with SGC to develop this active ICM concept. So basically, what it is that you can save sequence data, images, plots, chemical information, chemical spreadsheets along with text annotation and also 3D visualization, as we've seen with the slides. And you can save all of this into one multi-platform single file called an ICB file. And then you can view this file in a ICM Browser, which is the standalone platform, or you can import this file into the web, so you have text with hyperlinks to 3D structures, or you can import this into Windows, Office, and PowerPoint. At the time, this was a very unique concept, and it still is, with the amount of different information that you can store in one file. And so at that point, journals started to get interested in publishing their data like this, and you can see fully interactive 3D papers in PLOS One, Nature, Structure and Biology, and PLOS Biology. So the key thing is it's the one single file. And now, more recently, we've developed iMol View, which is for Android and iPad. So you can view these files which have text and links directly in iMol View. So you can contour electron density and things like that and display. So that's free. iMol View Lite is free on the iPhone and iPad, and iMol View is free on the Android devices. So I'll just show you how to do that. So we have all these slides. So we can save everything into one single file. We go to File, Save Project As, and let's give it a name. Okay. So we could export these 3D fully interactive slides into PowerPoint or onto the web. We can add different edit a slide, and we can add different transitions and blending transitions for each slide, just to make it a bit more. I'll just go here, right click. Okay. So if we save this project again, I've made some changes to it, we can import to PowerPoint. So to do that, go to PowerPoint, get a new slide. I'm using Windows Office 2007, but it's generally the same for 2010, and we've got all the instructions online. If you need them, I can send you those instructions. But you go to the Developer tab. You first actually you need to download Active ICM, which is from which is shown here. So you need to download this product, which is a plugin, and then you go here. We go to the Developer tab. We click on this control option here, and we'll see that we have a control for Active ICM. Go OK. Then you can click and drag where you want to place your fully interactive 3D slide, and it will ask you where it's located, or where the ICB file is on your machine. You go Open. Now it's imported into ICM. So to display, we have to go to the only way to make it active is to do it in slideshow. So you go to from current slide, and then the slide is fully interactive. So you can just toggle through your slides like that. You can also display them in Anaglyph Stereo. So if you have any glasses handy, you can put them on now, and you can view them in stereo. And so that's in PowerPoint. I just want to go back here, and so for Anaglyph Stereo in the ICM browser, we have a button here with glasses. If you click and hold, you can choose Anaglyph, or if you have other hardware stereo, you can change it to different stereo forms. But Anaglyph is the most convenient. We just click on there, and you can see that I think it projects quite well on WebEx. If you have the glasses, you might be able to see in stereo, but you have the cyan and red outline. But with the glasses, you don't see that. Obviously, you don't see that color, and you see it in stereo. Okay. So if you wanted to, I'll just get rid of the stereo. If you wanted to export this to web, you go to File, and then Export as Active ICM HTML. And then you'll get the code that you can embed into your website. And just finally, you can also to show those transitions, you can toggle through. You can see that we have different blending and through the slides. So you may also want to, rather than having a fully interactive 3D view in your PowerPoint, or you may want an actual movie. So a movie can be made with ICM Browser Pro, which is the one step up from ICM Browser. So everything I've shown so far can be done in ICM Browser, but this option is in ICM Browser Pro. So we have a series of slides, and we can convert this slide, these slides directly into a movie. So it will go from slide 1, 2, 3 through to 6. If we right-click and we choose Export as Movie, we have the name of the movie file that we want to call it. We can add smooth transitions in milliseconds and blending in milliseconds. Add the number of still frames between each slide, and we go OK. Then this will write out all our slides into a movie file. Okay. So it writes it into your working directory. Just so you can just double click on and view that movie. Okay. There is another way of making movies which doesn't rely on slides, and you can just click on this camera movie button here, and it will record everything that you have currently in your 3D graphical display. So you can zoom in, zoom out, and it records everything that you have in your 3D graphics. But I think the slideshow way is a bit more of a controlled way of making a movie. Okay. So at that point, we come to the end of the webinar. So if you have any questions, please feel free to email me or call me. And I'll be here for the next 10 minutes or so, 15 minutes to answer any questions that you have. If you have any questions, please type them in the chat, or let me know, and I can unmute your microphone and you can talk to me directly. The next webinars the next one is next week on Tuesday, which will showcase the new features in the very latest version of ICM Pro. So it's new docking features, new modeling features, new fragment-based drug design and screening, as well as quite a few new things. So that will showcase those new features. Then the week after, we'll be talking about linking sequence to structure. So how to make an alignment in ICM, just for example like this, and then how to link the alignment directly to 3D. So you can, there's a variety of different tools inside this alignment editor that we'll be showing in 2 weeks' time. So I'd just like to thank you very much for your time, and thank you very much for joining us. And if you have any questions, I'll try to answer them now. Okay. I had a question about ICM Browser. So as I mentioned, you download it from here, and it will run. ICM Browser is the desktop, basically what I've been showing you, and you can run that on Mac, Windows, or Linux. The latest version 3.8 should be online now, and that has the Anaglyph Stereo included. It should be 3.8. It should be there. If it's not, let me know. But I think it's there. Yes, this webinar has been recorded, so if you're interested in it, I will email it to you so you can view it later. Okay. There's a question about how can I display the electrostatic surface representation. I didn't show that because in ICM Browser, you can display the properties of the pocket, the binding pocket, like I showed earlier. Here, oh, that's the generic one. Here, you can do this, but you don't have the option to display electrostatics. That's in ICM Browser Pro, so I didn't show that today. So if you have ICM Browser Pro or if you have ICM, you go to the Meshes tab and select, you just find a smaller object. You just select the object that you're interested in. Electrostatics. The occlusion shading is actually generated, is by default now, now that graphics cards can handle it better. We can go here and we can make the electrostatic surface for this molecule. Had a question about so the electrostatics is shown here. So we can display the display and ribbon. You can cut through the surface by clicking on this button here and dragging. So it cuts through the surface without cutting the ribbon representation, like that. Or you can lock that cutting plane like that. I had a question about some of the basics of hydrogen bonding and other things. That we do hold a workshop here in San Diego, if that's of interest. But if you have any specific questions, I can answer them by email about that. A question about displaying electron density maps. So we have this once again is not in ICM Browser; it's in ICM Browser Pro. So, for example, here we have one N5Z. We would need to go to the database, the Uppsala electron density map database, and type the code here to download the map, and then we can contour it. I'm not sure if there is a map for this structure, but we'll see. So this reads in the raw map. Yeah, there is. So so then we can contour. Let's just display some side chains. So we can select a region, and then go to Tools, X-ray. This is in ICM Browser Pro, and then contour electron density. Okay, you can see that it's contoured at two different levels, sigma levels, but you can increase or decrease that. Yeah, by just clicking on the plus and minus. So, okay. the presentation will be emailed, so I'll send it to the list of people that registered. So thank you very much for your time. I don't think there are any more questions, but I'll be here for a few more minutes in case you do have them. Thank you very much.